arithmetic series. So what's the difference between a sequence and a series? Okay, so here is a sequence. The first term is 3, the common difference is 2. And here is a series. Same numbers and same first term, same common difference, but in a series you work out the sum of the terms. To work out any term of the sequence or the series, it is the same nth term formula. So for example, the fourth term, n equals 4, so 2 times 4 plus 1, it gives 9. For a series, we also work out the sum of n terms. So there should be a formula here to work out the sum of any number of terms in this series. So for a series, an arithmetic series, the nth term formula, un equals 2n plus 3, and we want to work out the sum of the first 50 terms, which is summarized as S50, the sum of 50 terms. And this means the sum of the first 50 terms. So the first term plus the second all the way up to the 50th term. It's not the sum of any 50 terms, but the first 50 terms. These are the terms in the series. The first term is 5, the common difference is 2, and we have 50 terms. Now to add these together, we could put them into a calculator. That would be time consuming, but there is a shortcut, and that shortcut method leads to a very convenient formula. So here is the same series again, but I'm going to write the same series but in reverse order underneath this one, so the terms line up like this. And we're going to add these two series together. So if I add these two numbers together, I get 108. If I add these two together, 108 again, and you can see what's happening here. You always get the same sum when you add the numbers in pairs. If I add up all these 108s here, I will have added the series twice, so I know I have to divide by 2 at the end. But how many of these are there? How many 108s do we have? There were 50 terms in the series, so they are 50 lots of 108. So the sum of 50 terms, but we've got 2 lots of the series, so multiply that by 2. 108 times is 50 terms, 5,400, and then divide by 2, we get 2,700. There is a feature on the calculator up here that will work out the sum. That sigma means sum of. The sum of the first 50 terms. Instead of using the letter n, we're using x. It doesn't change anything. This is actually the nth term formula, un equals 2n plus 3. Here, replacing the n with an x. Okay, starting from the first term up to and including the 50th term, 2,700. But this is good for checking things with. It's not something that you should rely on for your method in exams. You're not really showing a method if you're doing it on your calculator. You need to show all of this. So to come up with a formula, I've written the sequence and the same sequence in reverse order, and I know this is my first term, and this is my first term plus a common difference, a plus d. So will this be? It'll be exactly the same. See, the next term here, the third term, would have been the first term plus 2 lots of the difference there. Or I could write it like this: a plus the third term minus 1 times d, or we can sort of generalize this into a plus whatever the term number is here, minus 1 times d. So if there are n terms in our series, the very last term is a plus n minus 1 times d. And this is the same series in reverse. If I add these two terms together, I get this sum. And the same is true if I was to add these two together, or these two, or these two. There are n terms in one of the series, and we've added the series twice, so 2 lots off the sum of n terms. So the sum of any one of these pairs, like this, is here, but because there are n lots of this sum, we multiply by n, and then finally, to work out the sum of n terms, we need to divide by this 2, so that's where the half comes from, dividing both sides by 2. So once again, the proof, we have all our terms algebraically. We reverse the series. If we add these terms in this pair together, we get 2a plus n minus 1d. There are n pairs, so this is the sum of both series. And then finally we divide by 2 to work out the sum of n terms. And here is the formula. It's given in the Edexcel formula book. Now there's an alternative formula for the sum of n terms, but you must know what the first term and the last terms are. The ones in between don't matter, but you must know the first and the last term. So the first term is a, and we use L for the last term. You have your other terms in between in the series. You reverse the series, and again when you add these together in pairs, it's a plus L. But there are n lots of these, so times n, but then you've added your series twice. So then you divide by 2, and here is another convenient formula. Again, it's in the formula book, you don't need to memorize this, but you must know the first and last term to use this formula. An example, the first term is 4, the common difference is 5 in an arithmetic series. What is the least number of terms for the sum to exceed 2000? So the sum of n terms greater than 2000. An inequality to solve. So using the formula for the sum of n terms, this formula, if we substitute the numbers in that we know, and then solve quadratic. Now n is the number of terms. It's a term number. It's got to be an integer, and it has to be positive. It can't be negative. So this solution is a nonsense. We can discard that. On this side it says n greater than a certain value, so the first whole number, the first integer greater than this value here is 28. So just to test, here are the sum of 28 terms, general formula, substitute the values in that we know. N is 28, I'm putting in 28 here and here. We know that A and D are 4 and 5, and that gives us 2002. That's a value that's greater than 2000. And now if we do the same thing for 27 terms, we get a number that's less than 2000. So the 28th term is the first one, where the sum of the series is greater than 2000. For practice, have a go at these questions. It's the second year textbook, chapter 3.